This is a series of presentations on climate where I will be finally talking about geography. My name is Sean Han. I'm from class 8D from Huitong School, and today I will be talking about part 1 of a series of lectures on climate. The first one being climate factors. So here are the contents. I'm going to go ahead and give an overview of climate factors, then some talk about wind currents, and finally ocean currents. To start this off, let's start off with a little bit of an overview. Now, there are two kinds of currents: wind currents and ocean currents. And they are all generally created in very similar ways. They're always created, well, let's start off with wind. Wind is created throughout a series of low and high pressure areas. When the sun goes ahead and heats up the Earth's atmosphere, it goes ahead and makes out these areas. For one part of the area, it will be low pressure, and on the other part of the area, there will be high pressure. Now, if you know basic science, you will know that when there are different concentrations from different places, those concentrations want to balance each other out. So high pressure air goes off into low pressure air. And that rush of air from high pressure to low pressure is what causes wind. These arrows shown in pink is what we call wind. Wind stops when equilibrium is reached, and of course there will have to be wind currents. Now, of course, there are a lot of global wind patterns shown here on this map, where hot air goes ahead and goes to the poles. Let me use red for hot air. From the equator, hot air goes ahead to the poles. Whereas in turn, cold air goes from the poles to the equator. And as you can see, there's a current. There's a loop-the-loop of wind. Hot air goes to the poles and comes back down as cold air. If the Earth was not rotating, of course all of this would actually go ahead and go in straight lines. But since the Earth is rotating all the time, it goes ahead and all this wind, instead of blowing in straight lines, goes ahead and blows in curves at angles. And it's mainly because of the orbit of the Earth, as I've just mentioned. And from the north, it goes to the right. At the north, the wind goes off into the right direction, while in the south, it goes off and blows into the left direction. And of course, of all those wind currents, you can go ahead and create these kinds of things. Now we have ocean currents. This is how you can go ahead and describe ocean currents. They are very similar to rivers, except instead of rivers beside land, such as the drawings shown over here, instead of like rivers on land, it's rivers inside other bodies of water. It's a river inside a body of ocean. It's like a separate piece of water that goes on its own. And it's these things that can actually go ahead and affect the climate very much. Here is a map of almost all the main currents, ocean currents. And here's a little bit of an explanation. All these currents go ahead and move in circuits. There are circular system, and the equator shown in yellow here. Actually, it's already shown there, but hey, I'm just gonna draw it again. The equator shown in yellow here. It goes ahead and there's flowing water to the pole. It goes ahead and makes water flow towards the poles. And it's hot water. It's warm water. It's warm water. If it was hot water, well, the Earth would die. And it goes off to the poles. But then, just like wind, oh wait, that's impossible. But then again, just like wind, like what wind does, from the poles to the equator, there goes cold water, will you say. And this is actually goes ahead and what keeps the whole world cool. It's like the entire world's version of an air conditioner. It's like an air conditioner for the entire Earth. And that's practically the best analogy I can give out to ocean currents. And with that in mind, you can go ahead and infer that there is a lot of currents going ahead inside this world. In fact, these currents that goes ahead and keeps Europe cool, even though it is just a little bit lower than Canada. It's just a little bit higher than Canada in some regions. It's actually kind of warmer than Canada, mainly because, well, of these Gulf Streams. The Gulf Stream goes ahead and gives out its warmth towards the north, towards the northern Europe. Even though it's in the northern part of the northern hemisphere, where it should be cold, it's actually warm and quite moderate. Not to mention the North Atlantic Drift goes ahead and helps the Gulf Stream do its job. And on some coasts, there are actually cold ocean currents that go ahead, and that's why basically some coasts, those all the coasts, the temperature, the climate is actually pretty cool instead of very very warm. And with that in mind, there is a lot that you can go ahead and do. Ignoring all these ocean currents, and if ocean currents actually go ahead and did not exist, well, then we'd be in for a big trouble. And this area would be hot, and these two areas I just located here will be colder. And thank God they aren't. And in fact, some of these ocean currents go ahead and affect the temperatures and climate so much that they go ahead and create new regions in the world, such as the Atacama Desert in South America, Atacama Desert in South America, as well as the Namib Desert, which is in Africa. And that is all about ocean and wind currents. Ocean and wind are two things that cannot exist without the other. If it wasn't for low pressure and high pressure and winds, oceans would not exist, and vice versa for winds. Here is a list of key points you can take from this lecture. So, currents, whether it's wind or oceans, well, technically this time wind, they go ahead and they're all caused by transfers of heat. Upward motion of air goes ahead and makes winds as well too. Sun heats up the atmosphere, which heats it up, and then all this heat is transferred throughout the entire place. And then wind currents start happening, and so the creation of wind is what happens. So the sun heats the atmosphere, so the air expands. Oh, and high air pressure zones are created, and so low pressure tries to balance this out by giving some molecules towards low pressure zones. And with that, just go ahead and try to remain equilibrium, try to maintain equilibrium. And then we have ocean currents, which are like rivers in oceans, and they move in large circular systems. From the equator to the poles, they give out warm water, and from the poles to the poles to the coldest to the equator, you get cold water. And so winds over oceans actually go ahead and affect climate, because wind over oceans, wind is going ahead, its temperature is also kind of affected by the ocean beneath it. Also, it can travel on places, it can also travel mostly on ocean places. And that's pretty much what all this is about. So thank you for watching my presentation, and I will see you in my next presentation about climate biomes.